You know the game of telephone where one person whispers a message to someone, and then they whisper it to somebody else, and so on, and often by the end, the message has gotten all messed up? So, the message in a piece of data doesn't always get transferred correctly either. Over the past several months, with all the focus on COVID-19, a post with this figure, I added the highlighting, and some others similar to it, came across my social media feed several times, including recently. I think in every case, the graph was used to suggest that rates of COVID-19 were decreasing in Columbus, Ohio, which is the focus of the data set and nearby for me. The thing is, it turns out that's a completely wrong interpretation of these data. Now, at first glance, it's pretty easy to see why the graph would get interpreted that way. For example, one aspect of this graph is the number of COVID-19 hospitalizations in the city. Those are the red parts of the bars, and they're plotted by date of disease onset. The dates are ordered along the x-axis or the bottom, with the most recent dates on the right. And the bars for those most recent dates are clearly small, so it does look like things are going down. But like I said, that's not an appropriate conclusion from these data. In fact, you can't really interpret much at all about what's happening in those most recent days from this plot. If it's not clear to you why, and you want to test your data interpretation skills a little bit, hit pause and give yourself a little time. The title of the video offers a hint, but I'll go ahead and explain now. When you interpret data from any graph, it's really important that you understand exactly what's being plotted, or in other words, what the variables on the graph are. While this one does show counts of hospitalized cases, it's not plotting the date of hospitalization. It's easy to jump to that assumption, but instead, the data are plotted by the date of disease onset. And while that might sound like a subtle difference, plotting by date of onset versus date of hospitalization, it has critical implications for drawing a conclusion here. A little thought experiment should make it clear why. Imagine you start feeling sick on a Monday. Symptoms aren't that bad, so you give it some time, hope it's just allergies, or maybe you can fight it off. But over the next few days, you progressively feel worse, until Saturday when you finally give in and go get checked out. The doctor asks you about your symptoms and establishes a date of onset based on when they started. That's what's being plotted in these graphs. That means the bars on the far right of the plot, those most recent dates, they're expected to be small because most of those cases won't get counted for at least several more days. Now, this plot actually comes from a report that's released on a weekly basis by the local health agency. The numbers just get updated each week. I put a link and a comment pinned to this video if you want to check it out. So we can look at the current version of the plot, which I have here on the bottom, and compare it to what these data looked like in April. For the same dates, here roughly April 15th through 20th, the values are clearly different now, simply representing a more complete data set. The take home here, it can be easy to look at a graph and pick out a pattern that might make sense based on an assumption about what it's showing, and/or that might reinforce some preconceived idea, whether it's right or wrong. It's an easy trap to fall into, and if you want to interpret data in an appropriate way, you have to work to make an explicit effort to avoid it. It's important that data speak for themselves and not for the person doing the interpreting. If you're going to draw a conclusion from a graph, do what you can to ensure you're clear about exactly what the variables are that are being plotted. It really can make or break the conclusion you draw. Thanks for checking out this video. If you found it useful and you're interested in similar videos, feel free to like and subscribe.